the forward-looking statement and risk notice. So, as you heard in that great introduction, Euro Manganese has a project in the Czech Republic which is focused on delivering a fully traceable supply of high-purity manganese, which is required for the electric vehicle battery industry. We are set to become the only producer of high-purity manganese in Europe, based off the only sizable reserve of manganese in the EU. Obviously, the EU is a very fast-growing EV battery market, and the Czech Republic is right in the heart of that. And the EV battery market and the shift to EVs is an essential component of the shift to a net zero carbon economy. We're well funded. We had 28 million Canadian dollars as at the end of last quarter, with the European Bank of Reconstruction and Development, which is an EU institution, as our second largest shareholder, who invested $8.5 million just at the end of last year. One of our aims is to have best-in-class environmental and social performance, which is becoming increasingly important for the customer base and also the financial institutions that are looking to support the project. We have a great team with deep experience in the high-purity manganese industry, and my background is I was with Lynas Corporation, the rare earth company, on the first 9 years of that journey from exploration through development into what is now an $8 billion company. And I was a key part of that journey. We see our flagship project, the Chvaletice Manganese Project in the Czech Republic, as the first step in building a multi-asset manganese platform. So why manganese? Manganese is an essential metal in the cathode of the electric vehicle battery. So a typical cathode is nickel, manganese, cobalt. The example here is a NMC 622. That's about 60% manganese, 60% nickel, 20% manganese, and 20% cobalt in weight. But as you can see, the value or cost of each of those components is very different. And manganese is the affordable battery metal, meaning it's the lowest cost of all those metals, but it plays an essential role. The extremely strong growth in the electric vehicle battery industry means that high purity manganese demand is forecast to grow tenfold through to 2030. And even with all the projects that are being talked about, some of them, possibly into production, maybe skeptically into production, but putting all the projects together, there is a forecast deficit. That manganese demand could increase even further because battery manufacturers are looking at ways to develop lower cost cathode chemistries, which is the most expensive part of an electric vehicle battery. And the battery is the most expensive part of an electric vehicle. So to enable a wide adoption of the electric vehicles, they need to reduce cost. The best way to do that is to develop a high manganese cathode chemistry to lower the cost of the cathode. And here are some examples of well-known companies in the industry with these new high manganese cathode chemistries, BASF being a prime example. That battery has 70% manganese, which was significantly lower the cost of that battery. CATL, the largest Chinese battery manufacturer, has announced the development, the commercialization of a manganese-containing LFP, which is lithium iron phosphate, which is another type of battery chemistry. So the demand curve on the left excludes LMFP and these very high containing manganese chemistries. The other aspect of the supply chain is the move to locally sourced low carbon materials. The OEMs, the battery manufacturers and the cathode manufacturers have all stated that they want to move to local production and local content for their batteries to secure their sustainable supply chains. This is now being backed up by regulation. The Critical Raw Materials Act in the EU, looking to build more resilient supply chains and sustainable supply chains. The Inflation Reduction Act in the US, focusing on incentives for local content or from friendly countries. So Euro Manganese is very well positioned to benefit from that localization of resource. Because as today with many of these battery metals, 90% currently is produced in China. So specifically on our project, here you can see the tailings of an old mine that was mining other metals, not manganese. So the manganese in these tailings is very uniform. This tailings was laid down in the Soviet Czechoslovakia era between 1950 and 1970. There's 27 million tons of reserves, with 98% at the proven category, with an average grade of just over 7% manganese. That is enough for a 25-year mine life, producing just under 50,000 tons of manganese equivalent product every year for 25 years. Our environmental and social governance aspects of our project are unique. These tailings are currently leaching over 1 ton of sulfates into the groundwater every day. But as we process this material and remove the manganese, we will place our tailings back to these stockpiles, but properly lined using best available tailing management practices, and that will stop the pollution that's currently ongoing at the moment. We have also signed with one of the Europe's largest renewable energy companies to provide 100% renewable electricity to the plant. We are also not using any fresh water. We're using industrial wastewater from a neighbouring power plant for our process makeup water. And we're even recycling some of our own process emissions. All of that adds up to a best-in-class environmental performance with the lowest CO2 footprint in the industry. We have just completed a benchmarking study against our current producers, and we are approximately one third of the CO2 footprint of those other producers, which puts us way ahead of the competition when the battery companies are looking for a low carbon source material. You can see the processing plant here is right next door to the ore stockpiles. So there's no carbon footprint from long distance ore transportation. Typically, material is mined in Africa, transported to China for processing, and then transported to the market. We have very good local community relationships, which is very important in Europe. The Czech and very good support from the Czech government. We'll be creating 400 jobs locally and contributing over 1.5 billion in corporate taxes and royalties over the life of the project to the Czech government. Our process, the core process, is the same process that's being used in China, so there's very little process risk. We have to wrap tighter environmental standards to meet European and Czech environmental standards, but that's essentially the only difference. Apart from our raw material is already finely ground, so there's no blasting, crushing or grinding required. We just excavate and then put that into our process, the first step of which is a magnetic separation. That allows us to upgrade the material, and then we go through a leaching purification to produce a metal, and then that metal is produced into a high purity manganese sulfate, which is what the industry requires. We have recently taken delivery of a demonstration plant in the Czech Republic. We have produced kilograms of samples from a pilot plant in China, but now this demonstration plant will produce tons of samples for the next stage of product qualification for our customers. The project is very robust. The net present value using base case pricing is 1.3 billion on a post-tax basis. That gives a 22% ungeared post-tax IRR with strong margins. The capital cost of the project is $750 million. And we will be funding that through both debt and equity. We have engaged a London-based bank, Stifel, as our debt advisor, and we're getting very strong support from the European institutions. The European Bank of Reconstruction and Development, as I mentioned, was one of our largest shareholders. They want to be one of the cornerstone debt providers, as do the European Investment Bank. But also good support from the commercial banks, typical ESG-focused funds, export credit agencies. And we're also seeing at the moment in the industry that customers are providing financial support to battery raw material companies. So our timeline is we're about to submit our final environmental social impact assessment. That's a 6-month process, and then we can submit our land planning and construction permit for permitting to be complete in the second half of 2023. Alongside that, we'll be putting in our project financing, both debt and equity, and looking to make a final investment decision at the back end of 2023. And we've also now released our tender documentation for our engineering, procurement, and construction management, which is the next phase of the project. And obviously putting in customer offtake contracts to underpin that project finance. I talked about a multi-asset manganese platform, and we're now focusing on our growth horizon in North America. And we're looking to set up a plant in Quebec, the first stage of which will use metal from our Chvaletice high purity project, but ultimately we want to build a completely independent North American supply chain. So in summary, we have a privileged asset in our ore body, the only sizable manganese reserve in the EU. We have excellent ESG credentials, which make us a partner of choice, both for the customer base, but also for the financing institutions. We're well funded at the moment. with $28 million at the end of last quarter. And we have a solid management team who's built these type of projects before and now has a deep, high purity manganese experience, which we can use in Europe and also take to North America. So Shishi, thank you very much for your attention. I'm happy to answer any questions.
Thank you, Dr. James. A few questions here from the audience. And one of the first ones from Merit B is asking, maybe you can tell us a bit more about the potential, what's the potential of the manganese market overall, and where are the metals now mostly produced from?
So most of the ore comes from Africa and is shipped to China, inland to the processing plants in China. I think the manganese market is moving into a twin market, one that's focused on North America and Europe, looking for their own supply chains to be secured locally, and then the Chinese market supporting the Chinese industry, which is also growing very rapidly. So there's plenty of manganese in the world, but there's very limited high purity manganese. And the grade of purity that's required for the electric vehicle battery industry is almost close to a pharmaceutical grade. It's the impurities which are have to be very, very, very low, because that's what can cause problems with batteries shorting and fires, etc.
Great. Another question from Malone is asking, similar to the last question, are there any other similar manganese projects in Europe?
No, we are the only one.
Good to hear that. One last question from Wen, and who will be your, I would say, ideal partner? Let's say, who's your ideal partner?
We're talking to customers right along the value chain. So the big chemical manufacturers like BASF and Umicore, who are the two biggest cathode manufacturers, they would be ideal partners. We're talking to the battery industry themselves, but we're also talking to the OEMs who have shown examples where they want to secure their own supply. They're no longer leaving the supply to their tier one manufacturers. They're going upstream and doing direct contracts with lithium, nickel, cobalt companies, and we expect to be the first manganese company to get a OEM contract.
And just time to let me throw in one last question from Grace. Listen clearly. What is the anticipated shelf life of manganese enhanced battery compared to the ones in the market this time, and any possible cost advantage compared to the current batteries?
I don't think there will be any difference in shelf life or length of operating. The high manganese batteries have a similar profile of energy density and size. The benefit is a much lower cost because manganese is substantially, it's like 50 times lower in cost than cobalt, for example, which is what it will mainly replace. And it's cheaper than nickel as well. So there are companies that have announced high manganese chemistries for their mainstream and entry sort of level vehicles, because they have to make them accessible to the masses. You can't have, high price electric vehicles only for the premium sector. If we're going to reach 100% electric vehicles by 2035, which is what Europe and the US are looking to do.
Okay. Yes, so thank you again, Dr. James, for your time here to share with us, and also answering all the questions from the audience today.
It's a pleasure. Thank you very much.
Thank you.